Hi students, good morning to all of you. I welcome you all for the session. Today we'll be going to discuss on continuation on second chapter, relations and functions. So in last class we discussed about Cartesian product of sets. In last class we discussed about Cartesian product of set. This Cartesian product of sets, product means what? Suppose when we are having two sets A into B, product means what? Into or cross. So this Cartesian means what? Cartesian product of sets. This A cross B we are writing in a pair. We are writing in a pair like this. A into B is A B D E. So we are writing in a ordered pairs that will be called as a Cartesian product of pair sets. Okay, we are writing these pairs in a ordered pairs. So ordered pairs. So ordered pairs means what? So suppose it will be start from the A B C D and it will be the pair will be start from 1 2 1 3 and then after 1 it will be start with the 2 1 2 2. So these things will be called ordered pairs. And in last class, in last lecturing hour, I have been shown I have written some wrong about functions. So I have shown the example of two sets as a function and non-functions. But for both set, I have been written as a, so B is not a function, B is not a function, and also A is not a function. Make a correction of A is a function. Okay, just do the correction of A is a function. But I have written A is not a function. But I have given the example of A is a function and B is not a function. When we will be saying A is a function, so the pair is having single image. So the pair is having single image. The pair is having single image. Means what? So these pairs are written in different. Okay, means the elements are not repeating. So here 1 2, so 1 1 is not repeating, 1 3 is not repeating, it is having a single image. And so this set A is not having, this set is A is not having a repeated pairs. Repeated pairs is not also there, but within the pair the elements are also not repeated. So then this set, we can say this set is having a single image. So this set is having a single image, therefore it is having A is having a function. So A is having a function relation. A is having a function relation. So what is the functions? The special type of relations are nothing but a functions. Special type of type of relations are called a functions. So here when we say B is not a functions, so B set is not having a single image. When the set is not having a single image, not having a single image, so then we will be saying this function is a not this set is a not having. So when then we can say B is not having function relation. So I will be give the example. Suppose B is containing the 1 comma 2 and 2 comma 2 and 3 comma 4 and 1 comma 2. So we can say B is not a function, is not having function relation, because here 2 repeats. Okay, within the pair the elements are repeating, and 1 2 here pair, this is also repeating. The pair is also repeating, and within the pair the elements are also repeating. Then this set is not having a single image. Then therefore we can say that this B is is not having a function relation. B is not having a function relation. Okay, this is clear, right? What is the function relations? Okay, now that relations. Okay, so relations, as in previous classes have been shown with one examples, and also just I will remind a reminder of what is the relations. So relation is that in our daily life we are having relations of a father, mother, son, teacher, student, Like that also we'll be having relations in mathematics. So in mathematics also we'll be having a relation between the quantities. Suppose a is greater than b and the c is less than d. So these are the condition, less than, greater than, and line, this line m, you say line is m, is parallel to n. So these are the relations. Okay, these are the, we say as a relations. I will be give example here. So relations means what? Suppose I'm writing here one set 1 2 3 4 5 6. Okay, yes, I'm writing here set 1 2 3 4 5 6. I'm writing I'm writing relation of a to the a. I'm writing here a relation of a to the a by this condition. The relation condition is that x comma y such that, so y is equal to x plus 1. So we need to write a relation between a to the 8. There may be more sets will be there, but I'm taking only one set. So I'm writing the relations a to the a. So by these conditions, by this condition of relations, how I can write? So I will write a is containing 1 2 3 4 5 6. I'm writing here 1 2 3 4 5 6 in vertical directions. Okay, okay, this is, I'm comparing a, this is a set, this is a set, and with another set I'm comparing. So another set means it is a only, it is a 1 2 3 4 5 6. I'm comparing these two, the same set. Okay, I'm comparing these two sets are same set, a to the a, because we are comparing a to the a means the set is same. So here with these conditions means y is equal to x plus 1. So suppose you take, this is the x terms. Okay, x is x 1 2 3 4 5. Then what is the y? What is the y? X plus 1. So 1 plus 1 is 2. Okay, suppose you take, this is y. Okay, these are the x and these are the y's. Then and then the x is equal to 1. What is the y? Y is 1 plus 1 2. Okay, then we need to compare 1 2, and this is 2, 2 plus 1 3, and 3. So 3 is here, and 3 plus 1 4. Here this side will come 4, then it is 4. X is equal to 4, 4 plus 1 5, and this side will come as 4 to the 5, 5 to the 6, and 6 plus 1 7, 7 is not here. Then we can write here a relation. So relation 1 comma 2, 1 comma 2, and here 2 comma 3. So 2 comma 3, and then is 3 comma 4, and then is 4 comma 5. So and then is 5 comma 6. Okay, this is the meaning of relations. This is the meaning of relations between the sets, or relation of the sets. Of definition of relations. Okay, we define the definition here. So our relations, our relation are, so we usually, the relations will be obtained from a two non-empty set, from a non-empty set, from a non-empty set A to a non-empty set, to a non-empty set, to a non-empty set B, is a subset of, subset of the Cartesian product. Cartesian product A cross B. Okay, so we are making so what is the statement of this? So statement is not completed. I will write one more time, but I will show here what is the meaning of this. When we are making relation A to the B, when we are making relation A to the by the some relation conditions, then the we'll be getting the elements, the relation of the elements, the relation of the elements will be getting the pairs. Will be getting in the, in terms of pairs. So it is nothing but a subset of A cross B. It is nothing but a subset. The subset means what? This how we are getting this subset we are getting, the subset is derived. Okay, this subset is derived by describing The subset is derived by describing a relationship between the first element and second element. First element and second element. Second element of the ordered pairs in A class B. Okay, this is correct. And now this pairs we are getting only when we are making the relations between two sets from making the relations between two sets from the first element and second element of the pairs in A class B. Okay, then second element. So the second element what we are having, the second element are the image of the first element. The second element are the, so the second element is called, the second element is called the image of, called the image of the first element, called the image of the first element. Now this is over. Okay, now you, this definition is clearly defined. Okay, so a relation is obtained from two non-empty sets, set A and B is a subset of A cross B, is a subset of A cross B, and the subset will be obtained by describing the relations between the first element and the second element of the ordered pairs in the A cross B. Okay, this is the proper definition of a set. Now we'll be going to define what is the domain and range. Okay, the domain and range will be defined from this definition only. So domain means what? So domains, this means the set of all the first elements. The set of all first elements. The first of all first elements means from the first set. First elements of the ordered pairs. Of the ordered pairs. Ordered pairs means what? Ordered pairs means the pairs which are matching to the B. Ordered pairs are ordered pairs in a relation. So in a relation from set A to, from set A to B. From set A to B is called domain. Means I will show here in the example. So what is the domain? So domain are the first elements. First elements means the elements of the first set which are matching to the second set, which are matching to the second set. Which values are matching? 1 2 3 4 5 5 are matching, but 6 is not matching. So 6 is not matching. Then so here domain is what? Domain values here in this set, domain values are what? So 1 2 3 4 5. Okay, here domains are 1 2 3 4 5. Okay, and range, the another term we will be going to discuss what is the range. So range means the set of all second elements which are matching to the first element, matching the first element or first set. Which values are matching? So without one, 2 3 4 5 6 are matching. So then here we can write 2 3 4 5 6. Okay, now you understood what is the domain and range. And one more term will come here, codomain. So codomain means the set of all elements in the second set or second element. The set of all elements. So codomain values are 1, 2, 3, 4, 5, 6. All values. So all values of the second element or second set will be called as codomain. Codomain. You understood now what is the range. So range is what? The same definition we will be going to write here. The set of all second elements, the set of all second elements. Okay, the second set of all second elements of the ordered pairs from set in a ordered pairs in a relation, so from A to B. Okay, the remaining things you write same. Okay, and then codomain is the set of all elements of the from the set second set. A second element will be called as the codomain. Okay, now now you understood properly what is the meaning of range, domain, and codomain. Now we'll be going to discuss. Okay, so now this relation. So this relation we can present in a pairs. or in a terms of A cross B. So this we can present in both form. One is in a set builder form. So we can able to present in this both the set builder form and roster forms. This we can present in a set builder form in, or also we can write in a roster form also. Okay, now we'll be going to discuss the example. Then you will be understanding what is the meaning of. Now we'll be going to see. We'll take some example. So example, you say example one. So here let A. So A contains 1, 2, 3, 4, 5, 6. So define a relation. So define a relation. So define a relation. Uh, define a relation from A to A. Okay, from A to A by the condition R is equal to x y is equal to y x plus 2. Okay, so here the set is same only A to A. So just we write A set is 1, 2, 3, 4, 5, 6. Only 6 elements are there. So 6 are there. Then we can write relation. Then we can write a relation is in a pair. Suppose you take these are A. So A containing 1, 2, 3, 4, 5, 6. And another set is also A, that is 1, 2, 3, 4, 5, 6. Okay. So when we put the value of 1, so according to relations x plus 2 is what? 1 plus 2 is 3. Okay, we'll get 1 3. So this relates to sorry. So means what? Here 1 3 means here 1 and here 3 we are having. Then it is matching. When we put the value of 2, so when we put the value of 2, first element I am writing here, and second element which are matching to the condition, then I am writing from this second set. When we put the value of 2, 2 plus 2 is 4. So 4 we are getting. When we put the value of 3, so 3 plus 2 is what? 5. So 5 we are getting here. When we put the value of 3, then 5 will be getting. When we put the value of 4, so 4 plus 2 is what? 6. So 6 is here. 4, when we put the value of 4, the second element we are getting as a 6. Okay, this is over. This is over. When we put the value of 5, 5 plus 2 is 7. 7 is not here. Then we cannot write. This is over. Okay, this is the relations. This is the relations what we have got. And this we can write in a, suppose if in your examination will be asked, write this relation in a arrow diagram. So arrow diagram means what? The first set we have to write as 1 2 3. Okay, 1 2 3 4 5 and 6. Okay, so the another set is also the same here. So I'm writing 1 2 3 4 5 and 6. So now we are comparing. When we put the value of 1, then 3 we are getting 1 3. So 2 4 3 5 and 4 6 we are getting. So this is called arrow diagram. Okay, this will be called as a arrow diagram. Arrow diagram. Then find the value of domain. So what are the domain and range and codomain of relation? Range of R, domain of R, and codomain of R. Codomain of R. So as per the definition is clear. So domain means the first elements which are matching to the another set. The first elements which are matching to the second set. Which values are matching? Only we are matching 1 2 3 4. So it is called as 1 2 3 4 are the domains. So 5 6 there is no relation, there is no arrow marking there. So then it is domain of R. And range is what? The second elements. The second elements are, so 3 4 5 6 are matching. So codomains means what? This all elements of the second elements are the elements from the second set. So all elements we have to write here 1 2 3 4 5 6. Okay, this is over. Now we go to the next. Now we are going to the next problem. So in sometimes the sometimes in examinations will be given a arrow diagram. From the arrow diagram we have to write a range relations. We have to write a relations in a set builder form and roster form. Okay, the arrow diagram, suppose in examination, your examination arrow diagram will be given. So 9 4 25 is given here. 5 3 2 1 minus 2 minus 3 and 5 given. The arrow mark are given. So from the 4 arrow mark are given. 4 to 2 is given. 4 2 minus 2 is given, and 25 to 5 is given, and minus 5 is given. So and we have to write this. These sets are called as P and Q. These sets are, we say, P and Q. Then we have to write a relation in a, so here we have to write a relation in a set builder form. In a set builder form, then also we have to write this relation in a roster form. And also we need to find what is the domain and range values. Third, we need to find domain and range. Okay, so here so you just here when we observing these two sets, so x is the first element, y is the second element. So first element means what? The elements from the first set are the first element, and the elements from the second set will be called as the second element. You just remember of that first element and second element difference. Okay, so first element means what? The elements from the first set, and the second element means what? The elements from the second set. Okay, when we observing these, so these values 9 is matching with the 3 and minus 3 means what? Here it is square of those values. So square minus 3 square is what? We'll be getting plus 9 only. Minus into minus will be get plus. So therefore here it is clearly observed that, so you just write here, it is clearly observed that from the ob, observed that from the arrow diagram, x is a square of y. X is the square of y. Okay, x is the square of y, right? So now we can write first the set builder form. Relations, we are writing a set builder form. Relations means what? It is in pair. So it is in pair means, so when we put the value of 9, we will be getting, when we put the value of 9, we are getting one is plus 3 we are getting, and minus 3. When we put the value of 4 is matching with the one is plus 2, and another matching with the minus 2, and 25 is matching with the one is 5 and minus 5. Okay, understood. And now second one we have to write in a roast. We have to write in a, sorry sir. Okay, here the first one is second. Okay, it is we have written solution of the second one, so it is in roster form. This is in roster form. Okay, now we will be finding the first one in a set builder form. Okay, now we can write in a set builder form. How we can write? For set builder form, so set builder R is equal to, so x y, first element and second element, such that such that x is a square of the x is the square of y, and x is belongs to P and y is belongs to Q. Okay, this is we have written in a relation in a set builder form. Then we need to find the third one. What is the domain and range? Domain means what? The values are matching from the first element, okay, to the P to Q. Okay, the values are matching from the P to Q from the first element. Which values are matching? So 9, 4, 25. Three elements we are having. All three elements are matching. Then we can write here. So 9, 4, 5. So what about range? Range, the values which are matching to the from Q to P. So without 1, so here 1 is not matching either. Without 1, we can write all elements. So we write here. So -2 is matching, 2 is matching, -3, 3 is matching, 5 is matching, -5 is and 5 is matching. Okay, this is called range. Okay, now this concept is clear, right? So now the one more here example I will give. So example number third. So sometimes the two sets will be given, A and B will be given, and we need to find number of elements. So number of relations, what will be the number of relations? Number of relations, there is a formula for the to identify number of relations, or sometimes it will be called as the number of subsets. So number of subsets. So the formula is that, suppose the set A, B we are having. So number of elements in the A is P, you say, and the number of elements in the B is Q, you say. Okay, and then what is the number of relations you will be get? Number of relations will be in the form of P, P raised to 2 raised to P Q. 2 raised to, it is a product of 2 raised to product of P in Q. So I will give example here. A is containing two elements here, 1, 2, and B is containing also two elements, 3, 4. So number of A is what? 2, and number of B is also 2. So the number of relations will be get. So number of relations are number of subsets are in the form of 2 raised to P and Q. So it is 2 raised to 2 into 2. So 4, 2 raised to 4. So 2 raised to 4 relations will be get, means here 4 pairs will be there. Okay, 4 pairs will be there. You suppose you write this A cross B. So 1, 2, and 3, 4, 2 dot 2 dot here. Write this A cross B. So A cross B will be getting 4 pairs. 1, 3. Okay, 1, 3 are matching. So okay, from here to here, here to we have to go. Okay, from okay, 1, 3, 1, 4, 2, 3, 2, 4, 1, 3, 1, 4, 2, 3, 2, 4. Okay, 1, 2, 3, 4. 4 pairs are there. Okay, 4 pairs. So, but number of relations we are representing in the 2 raised to 4. So, this is the meaning of so number of relations and how to find the relations and domain and domain range, all the meaning. Now we'll be solving the exercise. Okay, I just copy of that exercise. Okay, we'll be solving the exercise problem 2.2. Okay, okay. So in this exercise 2.2 will be solve all these problems. So A is containing 1, 2, 3, so on, and we have to define a relations from A to A by this condition. Our relation condition is given. So the elements, first element and second elements are belongs to only first only one set is given. Okay, then we have to write domain, codomain, and range. So what I will do here, so A is given what? To 1, 2, 3. The first problem we are solving. A is given 1, 2, 3. So on 14. Up to 14 will be there. So the condition is given here. Relation is given. So relation is given 3x minus y is equal to 0. So 3x minus y is equal to 0, and then y is equal to 3x. So y is equal to 3x means, so y is equal to 3x. So when we put the value of the first elements are nothing but x. Here the first elements are nothing x, and the second elements also, the first elements and second elements. The first element x, second element is y. The first element is from a only, and the second element is from a only. Up to 14 are there, because we have to make a relation of a to the a. Okay, we have to make the relation of a to the a. X and y are belong to the 14. Okay, only 14 elements we are having. When we put that, okay, when we are writing relations according to these conditions, when we put the value of x is equal to 1, so x is equal to 1, 3 into 1, 3. Okay, then when put the value of 2, then 3 into 2 is 3 into 2 is 6. When we put the value of 3, 3 is a 9. When put the value of 4, 3 4 is a 12. When we put the value of 5, 3 5 is a 15. 15 is not here. Okay, 15 elements is not here. Then we can stop here. So when we can stop here. Okay, so up to, okay, so 4 12. Okay, this is the relations we will be. This is the relation for the relation for the first given problem. Now we can write domain. So domain is what the values are matching from, okay, the values are matching from a to a. From a to a, the values are matching from a to a, means the first elements here we are having 1 2 3 4. Okay, the domain is 1 2 3 4. Okay, there's and range is what? The second elements. So okay, the second elements of the ordered pairs. Okay, ordered pairs means this is ordered pairs, right? So second elements are 3 6 from the relations. Range of this will be called as the range of relation. The second elements are nothing but a range. 3 6 9 12. Okay, 3 6 9 3 6 9 and 12. And codomains means what? All elements of the second set. The second set is second element means here y, and means the first element and second element is same here. Then we can write all values of 1 2 3 up to 14. Okay, so this is over. Now we discuss second one. So I just make down here, then we can write second one. So the second problem here, second one is given. So define a relation R on a natural numbers. So the relation is given x y. So y is equal to x plus 5, x plus 5, and x is a less than 4. X is the less than 4. Both x and y are belongs to natural number. Okay, both x and y are belongs to natural number. Then we know that natural numbers are natural numbers are what? 1 2 3 4 5 so on. Okay, these are the natural numbers. Suppose we are writing here. So according to this condition we are writing the relation. So when we put the value of x means what? Okay, here both element x and y are same. Then elements of the x and y are same. Then we can put the value of x. When we put the value of x, y, what will be get? So according to the relation, okay, when we put the value of x, then what value of y will be get in the relation? Okay. Y value will be written according to relations. The y value here will be written according to relations. Therefore we are saying relation from a to a, or sometimes will be called as a to b. Okay, so here when we put the value of x is equal to 1, x is equal to 1, so up to which values we can put here? Less than 4 means what? We can only put the values of 1, 2, 3 only. Okay, 1, 2, 3 value only we can put, because the condition is given x is less than 4. Then when we put x is equal to 1, we'll be get 1 plus 1 plus 5 is 6. Okay, when we put the value of 2, okay, 2 plus 5 is 7. When we put the value of 3, 3 plus 5 is 8. Okay, this is the pair we'll be getting. Okay, and now depict this relation using roster form. Write down the domain of the domain and range. The relation we have depicted in the roster form. This relation in the roster form. Okay, the condition is given set builder form. So we are writing relation. The condition R relation is given in this is in set builder form, and we are relation writing in the roster form here. And now we have to write what is the domain and the range. So domain here, what will be the first elements of all are called as of the ordered pairs. The first elements of the ordered pairs are called a domain 1, 2, 3, and the range is what? So range is the second elements of the ordered pair. So ordered pair means ordered relations. Okay, 6, 7, 8. Okay, 6, 7, 8. Okay, this is all. Now we come to the third example. Here, come to the third example. So A set, B set is given, and we have to define relation from A to B. By the condition is that here difference between x and y is odd, and ax is belongs to A and y is belongs to B, right? Or in a roster form. We have to write a relation in a roster form. So roster form means what? A set is given 1, 2, 3. 1, 2, 3, 5 is given, and B is given here 4, 6, 9. So here relation condition is given that difference between x and y is odd. Difference between x and y is odd. So A elements I will write here 1, 2, 3, 5. Okay, 1, 2, 3, 4, 1, 2, 3, 5. So when we these value B is given what? 4, 6, 9. So these value we have to compare in all sets. Okay, I am comparing. Suppose I take 1, 2, 3, 4, 5. 1, 2, 3, 5 I am taking, and these values I am matching with the 4, 6, 9. Okay, one is matching with the 4, 6, 9. 2 is also matching with the 4, 6, 9. 3 is also matching with the 4, 6, 9. And 5 is matching with the we are matching means we have to match with the 4, 6, 9. We have to match with the 4, 6, 9 and write down the difference. So 1, 4, what is the difference? 3. 6, 1, what is the difference? 5. 1, 9, what is the difference? 8. So 4, 2, what is the difference? 2. 2, 6, 4. 9, 2, 7. So difference is 1 here. Difference is 3, and 9, 3, 5. 9, 9, 3, 6. Okay, 9, 3, 6. 6 and 5, 4, 1 difference we have. 5, 6, 1 difference. 9, 5, 4 we difference have. Okay, now which are the odd values we are getting here? Odd values 3, odd value 3, 5, odd value. So here 7 we are having odd value. 1 is odd value, 3 is odd value, 1 is odd value, and 1 is also odd value here. But the 1 is repeats here. Okay, the repeat here repeat it means we don't have to take, means okay, here 1 repeats, only one value we have to take. Okay, then this one we have to write in a roster form. So suppose I will write a pairs in a ordered pairs. I will start from the 1 here. Okay, here 1 is not here, 2 is not here. So 1 is here, then we can write 1 3. So here 1 is here, 1 5 I can write. Only one we have to take because 2 it is repeats here. 1 is repeating means 1 5 1 5 will come, then so it will be 1 5 1 here 1 1 is there, 1 5 if we write the pairs 1 5 1 5 comes, then it is ordered repeat pairs we cannot write. So then 1 is over 2, 2 is not here, 2 is not 2 here only tick values only we have to write these tick values. Okay, these tick values we have to write. Okay, 1 is over, then we start from the 3. So 3 1, so any 3 is there, 3 is here, 3 3. Okay, 3 is over, then next we'll start from the 5. So 5 1, 5 1, and any 5 is here. Okay, no 5 then we can write here 3 5 over 7 7 2, and any 7 is here, no, no 7, then this is over. Okay, then this is over. So next we move to the next problem, fourth one. Okay, okay, we'll start fourth one. So fourth figure is given here, so shows relation between P and Q. Write this relation in a set builder form, roster form, and we have to write domain and range. Okay, the relation is clear here. So the relation is clear here. So fourth one. So the relation is what? If we do 5 3 6 4 5, here difference is there. 5 minus 2 is 3, 6 minus 2 is 4, 7 minus 2 is 5. Then what is the meaning of it here? So we can write in a roster form or in a set builder form. Okay, we can write in a set builder form x y. So x y first element, the second element from the P and Q. So x y such that y is x minus 2, y is x minus 2, and x is belongs to P and y is belongs to 2. Okay, this is correct. This is correct. When we put the value of x is equal to 5, 5 minus 2 3, y is 3, y is 3 here. Okay, put y is equal to x minus 2. When we put the value of x is equal to 5, this first element, then the second element will be at 3. So these are the second elements. These are the x values, these are the y values, and then put the value of here 6 minus 2 is 4. Okay, 4 is there. Then put the value of x is equal to 7. Will we get y is equal to 7 minus 2 is 5. 5 is here. Okay, then we have to write this one in a roster form. In a roster form. So roster form. So how we can write roster form? So when we put the roster form, we can write here. When we put the value of 5 3 we are getting, when we put the value of 6 we'll be getting 4. When we put the value of 7 we are getting 5. And this is in roster form. And what is the domain and range is here? So domain and range we can easily identify. Domain are the first elements, first element of the page 5 6 3 5 6 7. Okay, then range is what? Range is 3 4, second elements 3 4 5. Okay, this is over. Now we can go to the next problem. So fifth one. Okay, now we can go to the exercise fifth one. So fifth one is given here. So fifth one. So a fifth one is a set is given, and our relation will be defined here. B is exactly divisible by A. Okay, A is given 1 2 3 4 5 6, and relation here relation will be obtained from is obtained from A to A. So A to A, and the relation condition is given B is exactly divisible by A. B is exactly divisible by A. So means what? Suppose you take A is equal to and here A and B values. So A and B values are from the belongs to A, means only one set we are having. So we have to check. So A means these elements 1 2 3 4 5 6, 1 2 3 4 5, 1 2 3 4 5 6, and B is also 1 2 3 4 5. Okay, B is also 1 2 3 4 5. B is also we are having 1 2 3 4 5 6. Now we have to check B is exactly divisible by A. B is exactly divisible by A means what? So we have to check 1 is divisible by 1. Yes. 1 is divisible by 2. Not. No. So therefore this we can write here 1. So it is not divisible by 2. 1 by 2. And 1 is divisible by 3. 1 by 3. No. 1 by 3. 1 is divisible by 4. No. 1 is divisible by 5. No. And 1 is divisible by 6. No. Only one value we got here. Okay. Then second one 2. 2 is divisible by 1. Yes. 2 is divisible by 2. Yes. 2 is divisible by 3. No. 2 is divisible by 4. 2 is divisible by 4. No. 2 is divisible by 2 is divisible by 4 means 1 by 2 only we get. 2 is divisible by no. 2 is divisible by 6. 2 is divisible by 6. 2 1 are 1 by 3 will get. Okay, it is not divisible. 3 3 is divisible by 1. Yes. 3 is divisible by 2. No. 3 is divisible by 3. Yes. 3 is divisible by 4. No. 3 is divisible by 5. 3 by 5. No. 3 is divisible by 6. 3 by 6. 3 by 6 means what? 3 ones are 1 by 2 will get. Okay. No. Now next go to the fourth one. Fourth is divisible by 4. 4 by 1. 4 by 1. 4 by 1 is 4. Okay. 4 is divisible by 2. 4 by 2. 2 ones are 2 2. Yes. It will be divisible by 2. And 4 by 3. No. 4 by 5. No. And 4 by 6. So 2 3 the okay. It is not divisible by. Then next is 5. Okay. Then we have to come to the 1 minute. So 5 by 1, yes, it is divisible by 1. So it is divisible by 2. 5 by 2, no. So 5 by 3, no. 5 by 4, no. 5 by 5, it is divisible by 5. 5 by 6, no. 6 is divisible by 1. And 2, 6 by 2, yes, it is divisible by 2. 3, it is also divisible by 3. 4, 6 by 4, no. 6 by 4 means what? 2 3 is a 2, 2 is a 3 by 2. 6, it is divisible by 6. Okay. Then here we understand. We can write relation here from, so we can write a relation here. So when we, so one is, so one here, 1 2 1 3 1 2, and 1 5 1 2 3 6 we got. Okay, then we have to write here. So one we have to write here. So when we put the value of, so this one we have to write. Then with respect of here 1 is here. Okay, with respect of this is 1, with respect of 2, with respect of 3, with respect of this, with respect of okay, the b values. Okay, the b values is 1 2 3 4 4 5 6. Then we have to write here 1 comma 1 and 1 comma 2 and 2 comma 2 and here 1 comma 3 and here 3 comma 3 and here 1 comma 4 and here 2 comma 4 and here 1 comma 5 and 5 comma 5 and we can write here 1 comma 6 2 comma 6 and 3 comma 6 and 6 comma 6. So this is the relation we got from the when we are matching a to the a by b is divisible by a. Okay, this is the relation we will get. And now come to the next problem, sixth one. Now come to the sixth one. So determine the domain and range of the relation defined by x plus 5 and x is belongs to 0 1 2 3 4 5. So means what here? So here r is given. So r is given x comma x plus 5. So x is belongs to 0 1 2 3 4 5. So here x, this is meaning x and x plus 5 is the second element, that is y. Suppose if we put the value of x is equal to 0 1 2 3 4 5. So 0 1 2 3 4, what is the relations will be it? So suppose you put 0 1 2 5 when we put the 0 here, so 0 plus 5 is 5 and 1 1 plus 5 is 6, 2 2 plus 5 is 7 and 3 plus 5 is 8. When we put the value of 4, then 4 plus 5 is 9, 5. So 5 plus 5 is 10. Okay, this is in roster form, and now we have to write domain. Okay, what is the domain? So domains are the 0 1 2 3, the first elements. Okay, 0 1 2 3 4 5. Then range is what here? Range is the second element. The second element are 5 6 7 8 9 and 10. Okay, that is the meaning of this statement. Now move to the next problem, seventh one. So seventh one is relation is given x cube, x is the prime number less than the 10 in a roster form. In a roster form we have to write when in a roster form we have to write. Okay, seventh one, we know that prime number is what? It is divisible by 1 and its own number. We know that prime numbers are 2 3 5 7 2 3 5 7. So the condition is given less than 10. Less than 10 means only 2 3 5 7 are the prime numbers. Okay, then we need to find. So according to this condition x cube, then we have to write a relations. Suppose I'm writing a relations. When we put relations, when we put the value of 2, so y value will be x cube. X cube means 2 to the power of cube. So when we put the value of 3, so value of y will be 3 cube, and when we put the value of 5, this is 5 cube, and 7 is 7 cube here. Okay, 7 cube. Okay, now you can write these values. 2 3s are 8, 3 3s are 9, 9 3s are 27, and 5 3s is 125, 7 1s are 7 7 are 49, 49 into 7 is 343. Okay, then anything we have to write from the, okay, we have written in a roster form. Next, move to the 8th one problem. So 8th one is given, let A is equal to xyz and B is equal to 1 2. Find the number of relations from the A to B. So 8th problem is very easy. A is given xyz, A is given xyz, and B is given 1 2. So here number of elements of A is 3, number of elements of B is 2. So we know that the relations, number of relations will be exist, number of relations. So number of your relations will be exist in the form of 2 raised to p into q. So then 2 p is value is 3, 3 into q value is 2, 2 raised to 6. The number of elements which is in 2 raised to q, 2 raised to 6 will be get. Okay. Now number of relations from A to B is 2 raised to 6. Then we move to the next last problem. So we have to define a relations on Z. So Z is an integer. So the integer means it contain both positive and negative numbers, and A minus B is an integer. Find the domain and range. So A minus is an integer. A minus is an integer. So what is the domain and range? Suppose integers are when we are integers are minus values. So minus 3, minus 2, minus 1, 0. It also contains 0, 1, 2 positive numbers also. So then if you put the A minus B, so A minus B will be getting the numbers are infinite, and the so domain and range values are integers only. Domain are all integers. So value of domain all integers Z, and here range is also all integers which are infinite. Okay, here Z values are infinite, and if we do the A minus B, then the values will be are all values, all integers are nothing but a domain, and all integers also a range. Okay. Okay, now we have been completed the exercise. Okay, next class we'll be going to discuss on functions. Okay, and we'll be solving the exercise. Okay, I'm finishing this class. Okay, thank you for watching the video, and please subscribe the channels, hit the bell icons for notifications, and share to your friends. Thank you.